Hello everybody. In today's video, I want to continue our discussion of the control flow structures that we have available in the Go language by talking about looping. Now in the last video, we talked about the two ways that we have to introduce branching logic into our application, if statements and switch statements. Well, when we talk about looping in Go, things are actually going to be a little bit simpler because we only have one type of statement that we're going to have to learn. And that statement is the for statement. Now we're basically going to break this conversation down into three different parts. We're going to talk about simple loops, we're going to talk about how we can exit a loop early, and then we're going to talk about how we can loop through collections. Okay, so let's go ahead and get started by learning how to do some simple loops in Go. So in order to start our discussion about looping in Go, I want to start with this, perhaps the most basic for loop that we can create. So we're going to start with the for keyword, as you might expect, and then we're going to follow the for keyword with three statements. The first statement is going to be an initializer. Now this is the same as an initializer in if statements and switch statements, so we can add any kind of statement that we want here, and normally we're going to use that in order to set up a counter when we're using a for loop like this. The next statement that we have here is going to be some kind of a statement that generates a Boolean result, and that's going to be used by the for loop to determine if it's done looping or not. And then the last statement is going to be the incrementer, and normally we're going to use that in a situation like this to increment a counter variable. So if we run this, we see that we get the numbers 0 through 4 printed out. We could also increment I by 2, and there you see that we only get 3 iterations of the loop because I has the value 0, then it has the value 2, and then it has the value 4. When it comes through the next time, it has the value 6. Well, 6 is not less than 5, therefore the comparison operation results to false, and we exit out of the loop. So this is certainly possible to do, and you will occasionally see this, but the most standard way that you see these loops created is like this, using an increment statement. Now if you're coming from another language, you might be expecting to be able to do something like this. So maybe we want 2 variables to increment in our for loop, and so we're going to initialize j there, and then we're going to increment j with each loop. So if we go ahead and try and run this, we see that that's actually not allowed, because we have no comma operator in the Go language. So you can't separate two statements like this using the comma. So this is an error and this is an error. So if we want to do that though, we can use Go's ability to initialize multiple values at the same time by adding a comma here, getting rid of this part here, adding the comma there. And then we can't treat these as individual statements because you can only have one statement here, and in Go the increment operation is a statement, it's not an expression, so we need to figure out a way to do both of these at one time. So we will simply come in and set I and j equal to I plus 1 and j plus 1, and go ahead and run that, and now we have I printing out. If we add j here, we see that j prints out as well. We can actually increment j by 2 here, and we see that I and j are incrementing independently, and we have no problems here. Now just to come back and revisit that increment comment that I made earlier, you might be tempted to do something like this if you just want to increment them by 1. If we run that, we're actually going to get an error, because again, in Go, unlike a lot of languages, the increment operation is not an expression, so we can't use it as part of a statement, it is a statement on its own. So when you're just incrementing one variable, you can certainly do this because I++ is a statement, but we can't use that in combination with anything else. We can't use it as an expression. Something else that's interesting, let me go back to our initial example here so we can play around with this a little bit. So at first blush, if you're just coming to programming, this I variable might seem like it's something special because it's used up in the for loop, and the fact is it's a variable just like anything else. So we can do whatever we want with it. As a matter of fact, just to show you that, let me drop in this cool little bit of code. As you can see, what we're going to do here is we're going to take the modulus of I and 2, and we're going to see if that's 0. So basically we're checking to see if I is an even number or an odd number. If I is an odd number, then we're going to divide it by 2. If I is an even number, then we're going to multiply it by 2 and add 1 to it. It's just a couple things to play around with the incrementer. So let's run this and see if this actually goes to completion. And in fact it does, and you see that the I variable is going all over the place. So we start with 0, 0 is odd, so it divides that by 2, which stays 0. The next iteration, I is going to be 1 because we're incrementing by 1, so it's actually going to be multiplied by 2 and 1 added to it. So we print the 1 here, but then by the time we're done here, 2 times 1 plus 1 is 3, and so I is 3, that gets incremented to 4, so we're printing 4 out here. 4 is even, so we divide that by 2. 2 gets incremented again, so we print out the value 3. 3 is odd, So 3 times 2 is 6, plus 1 is 7. 7 is greater than 5, and so we leave the comparison operation. So we can do whatever we want with the counter. Now, just because you can play with the counter doesn't mean it's a good idea. As a matter of fact, normally it's very bad practice to manipulate the counter within the for loop. So maybe the best reason to show you that you can do this is to make sure that you avoid doing this, because there can be times when you're inadvertently changing the counter variable within a loop, and your loops might start to act really strange like we're seeing in this example here. Okay, so let's go ahead and restore our original example, make sure that that's running again. And it is. We're printing out the values 0 through 4 again. Now the next thing that I want to show you is that we don't actually need all 3 statements here. So one thing that we could do, let's just say that I is initialized somewhere else in our application, so we don't need I to be set up here, and we can run with this first statement being empty. Now you can't leave this first semicolon out, because if you leave that out, then everything's in the wrong place, and it thinks that this is going to be the initializer, and this is going to be the comparison operator. So if we try and run this way, we're going to get an error. But if we leave the semicolon in, then Go recognizes that we simply don't have an initializer in this for loop, and it executes everything the way that we expect it to. And of course that variable I is taken in just like we would expect. Now the difference between this format and the previous one is in this, I is scoped to the main function, but when we had this syntax here, I is scoped to the for loop. So if I tried to print the value of I out here, we're not going to get a valid value because I is not defined. But in this other form, when we're putting I out here, then I is scoped to the main function, and we are actually going to get the final value of I printed out, which is the value 5, because 5 is the first value that fails this test. So this is actually coming from this statement right here. Okay, the next thing that we can do, let me go ahead and wipe this out. We also don't need the incrementer value, so we can eliminate that. Now if I run this right now, we're actually going to get an error, because what this is going to do is it's going to generate an infinite loop, and in the Go playground, they don't let us do infinite loops, and so after it runs for a little bit of time, it's going to shut the process down on us. If we were actually running this in a local environment, all you'd see is the value 0 printed out over and over and over and over again, until eventually you got bored and shut the application down. Now we can, of course, since I is a variable just like any other, we can put the incrementer in here, and everything works just fine. So, once again, we have to remember to put the semicolon here. If we remove the semicolon, then Go doesn't know what the heck we're asking it to do, because this is invalid syntax. So if you have the first semicolon, you need the second semicolon. Now, this case does happen actually quite a bit, where we need a for loop and just a comparison operation. And this is how Go does do-while loops. So in a lot of languages, you have 2 more keywords. You've got the do keyword and the while keyword. And normally those work with simply a logical test, and then you have some other increment operation. So you either have an incrementer inside of the loop, or you're pulling the next value off the stack and comparing that on each iteration, or something like that. Well, Go has the same problems to solve, but it didn't make sense for the designers of the language to introduce a new keyword just for what is basically a special case of a for loop. So what they allow us to do is we, of course, can use this double semicolon syntax here, but you can also leave them both off. So if I run this way, we see that this works, and this is going to work exactly the same way as if we have both of these semicolons here. So this is a little bit of syntactic sugar. It's exactly the same construct. It's just you don't need to have the additional semicolons, and it reads a little bit cleaner. So in this case, our for loop is just doing a comparison operation. Go is going to assume that we're taking care of where those variables for the comparison are coming from somewhere else. Now the third form of a for loop that we have available when we're working with counters like this is the infinite for loop. Because we also have a situation with do-while loops in other languages where we need the application to run through the loop an undetermined number of times. And by undetermined means we don't actually know when to stop by an obvious logical test. We need some complex logic within the loop in order to determine when to leave. So in Go, the way that we do that is we simply leave off the logical test, and we run like this. So if I run this again, as you might expect, the playground's going to crash out on us because there's no way for the program to exit, and so it's just going to run forever. So we need some way to tell our infinite loop when it's done processing and when to leave. And the way we're going to do that is using the break keyword. Now normally the way that you do this is you'll put some kind of logical test inside of the loop. So we can say if I equals 5, then we're going to use that break keyword. And we saw the break keyword the first time when we were talking about switch statements. Well, the break keyword is actually more commonly used inside of for loops, especially this kind of infinite for loop here. So what we're doing here is if I is equal to 5, so we're going to print out the values 0 through 4. then when I equals 5, we're going to break out. So if we go ahead and run this, we get exactly the same values that we had before. Now when we do this, we actually leave the entire for loop. So execution of the loop stops, and we're done processing. Now another thing that we can do is use what's called a continue statement. So let me drop in an example that shows you that. So in this case, we're looping from 0 to 9 because we're going to keep incrementing as long as I is less than 10. And then we're checking to see if the value is even. If it is even, then we're going to use this continue statement here. And what this does is it basically says exit this iteration of the loop and start back over. So what's going to happen when we have 0, 0 modulus 2 is 0. So we're going to continue, which means we're not going to hit this print statement. When we have 1, 1 modulus 2 is 1, so we're not going to hit this continue, and we're going to print out 1, and then 2 is going to hit the continue, and 3 is not. So what we should see is we'll only print the odd numbers out. So if we run this, we see that that is in fact what happens. So continue statements aren't used very often, but they can be very, very useful if you're looping through a large set of numbers, and you need to determine within the loop whether you want to process a record or not. Now, to show you the next thing, I'm actually going to do this. This is actually going to print out a nested loop. So what we're doing here is a pretty simple example. We're starting with the variable I, initializing it to 1, and we're going to run as long as I is less than or equal to 3, and then we're doing the same thing with j on the inside. So basically I is going to be 1, then it's going to loop through j from 1 to 3, then I is going to be 2, it's going to loop through j from 1 to 3 again, and then inside this inner loop we're just multiplying the two numbers together. So if we run this, we see that we get all of the permutations of I times j, where I and j go from the values 1 to 3. So we get all of these values printed out, and everything works the way that we expect. Now what happens if we want to leave the loop as soon as we get the first value that's greater than 3? So what we want to do is something like this. So we're going to multiply I times j, we're going to repeat our logic here, and we're going to see if that's greater than or equal to 3. If it is, then we're going to break out of the loop. Now if I run this, we don't exactly get the expected result. And the reason for that is as soon as I times j is greater than 3, it breaks out of the loop. But the loop that it's going to break out of is the closest loop that it can find. So it's actually breaking out of this loop here, and this loop just restarts because there's nothing to tell it to stop. So you might ask the question, well, how do we break out of the outer loop? Do we have to have more logic here and check to see if I times j is greater than 3 again and then break out? Well, the answer is of course no. We do have a concept called a label that we can add. So a label is put together something like this. We're going to start with a word and follow it with a colon, and we're going to left justify that in our code blocks. So once I have a label defined, I can actually add the label after the break keyword, and it basically describes where we want to break out to. So since this label is just before this for loop, we're going to break out of the outer for loop. So if I run now, I get to the value 3. 3 is greater than or equal to 3, and so I break out of both the inner and the outer loop. The last thing that I want to talk about in this video is how we can work with collections with for loops. So we've seen this before. We have a slice of integers. In this case, we're containing the values 1, 2, and 3. And we've seen how we can work with this as a slice. So we can print this out. If we run this, we get no big surprise. We get the slice printed out with the values 1, 2, 3. But what happens if I want to work with each individual value? Well, we've seen how we can do this. We can pull out one value from the slice, and we get the value 2. But how do I work with an arbitrarily sized slice? So I don't know how big this slice is going to be at runtime. I want to be able to loop through all of the items within the slice. So the way that I'm going to loop through a collection is using a special form of the for loop called a for range loop. So I'm going to start that with the for keyword, as you might expect. And then what I'm going to get is both the key and the value for the current item in the collection. So I'm going to have two variables that I can set there. And then I'm going to set that equal to this special range keyword and then provide the collection that I'm going to range over. So what this is going to do is it's going to look at the collection here, and it's going to take each value one at a time, give us the key and the value, and then we're going to be able to work with those values independently. So inside of this, let's go ahead and just print out the value of the key and the value and run that. And you see that we get the indexes for the items in the slice, and we get their values. So the indexes are coming first, those are the keys, and then the values are the actual values in the slice. And this is the only syntax you have to remember when using the range keyword. You're always going to get this key comma value result coming out. So this syntax is going to work for slices and for arrays. So if we make this an array by just adding a size here, we see that we get the exact same output. We can loop over maps. So if I pull back the state populations map that we used for a couple of videos now, and loop over that, once again pulling out the key and the value, and ranging over the map this time. Then if I print the key and the value, I'm going to be able to split that out, and I get the state and their population printed out separately. And I can even use a string as a source for a for range loop, because what we're going to be able to do here is pull each letter out of this string as a character, and look at that. And we see that we do get each position, and now we get this numeric value, which if you've been paying attention over the last few videos, you're going to remember that this is actually the Unicode representation for that digit. So we can cast it back to a string by just using a simple conversion operation, and we see that we get each letter printed back out as we would expect. The other type of data that we can range over in Go is what's called a channel. Now, channels are used for concurrent programming in Go, and that's a topic for a future video. So I'm going to leave that topic right now, I promise. When we talk about parallelism and concurrency in Go, I'll revisit the for loop and show you how you can use for loops with channels, because there are some special behaviors that you have to be aware of when you're ranging over channels. Now, if I come back to this example and print this out, you see that we have access to both the key and the value every time. Now, this isn't always true. You don't always need access to the value, and this can lead to some problems, because if I only want to print the keys out and run this is actually an error, because in Go, you have to use every variable that's declared. So we got this situation where we've got this variable v, but we're not using it, and so that's going to cause us a problem with our application. Now, in Go, what you can do, if you only want to get the keys out, you can actually skip the comma value, and when you run that, it's going to ignore the value. But what happens if you get into a situation where you only want to print the value out? So if I restore this and I only want to print the value, of course I get the same error, but I can't just say this because Go is going to assign the keys to that. So what do? Well, in this situation, when you only want the values, then you can use that underscore operator, that write-only variable that we've seen a couple of times. And basically that's going to give a hint to the compiler that we don't actually care about the key, but we need this in this first position in order to get at the value. So when we run this, we do see that we get those populations printed out. Okay, so that covers what I want to talk about with for statements in Go. Let's go into a summary and review what we've talked about. In this video, we talked about the second major control flow construct that we have in the Go language, the looping construct. And we talked about how we're going to use the for statement for all of the loops that we need to do in Go. So we don't have to remember a do keyword and a while keyword and a for keyword. When we use the for keyword, that's going to allow us to loop over every collection that we have. We started by talking about simple loops and how there are three basic forms for the simple loop. We've got this first syntax, which is the most basic. That's the initializer test incrementer syntax. And we're going to use that initializer to set us up in our loop, normally by initializing a counter variable. Then we're going to follow that with our test. Our test is normally going to look at the incrementer to see if it's at a certain value that's out of range for our for loop. And then we've got an incrementer, and that incrementer's job is to move the incrementer along at every iteration of the loop in order to move to the next case that we want to loop through. Now, we also learned in this first syntax, we actually can leave the first and last statements on that out, but if we're going to use any of this syntax, we have to leave the semicolons in place. So leaving a semicolon out confuses the compiler. It starts to assign things to the wrong places, and so you're going to get an error in your application. So if you need an initializer or an incrementer, then you're going to have to use this full syntax. Now, the second syntax eliminates the need for the initializer and the incrementer, and it assumes that the test conditions are being managed somewhere else. So in this construct, you only have the for test, and as soon as that test is false, you're going to exit the loop. The last construct that we have is the for loop on its own, and that will run indefinitely until somewhere within your for loop, the break statement is called. That leads us to how we can exit early from a for loop, and we have three concepts that we talked about with that. We've got the break keyword that will break out of the immediate loop that's executing and continue the application execution after that loop. The continue statement is similar to the break statement, except for it doesn't break out of the loop, it just breaks out of the current iteration, goes back to the incrementer, and continues execution of the for loop at the next increment. Now, we can also use labels in our application and combine those with break statements in order to break out of an inner loop, and that's typically how they're used in Go. So for example, if you have a nested loop where you're iterating over two collections and you need to break out of the outer loop, then you need to set up a label and then follow the break keyword with the name of that label so that Go knows where to break out to. And finally, we talked about how to loop over collections and how the collections that we have available, there's quite a few. We've got arrays, slices, maps, strings, and channels that we can loop over, but they all have this similar syntax. We're going to use that for keyword, we're going to get a key and a value, and then we're going to set that equal to the range keyword followed by the collection that we're looping over. So the keys when we're working with arrays, slices, and strings are going to be the index within that collection, so you're going to have that zero-based index. With maps, we're going to get the key from that map. And the values are what you expect them to be. They're the value for that current index. Now, when we're talking about channels, it's going to follow very similar syntax, but channels have a little bit of a special interpretation for these, and we'll talk about those in a future module. Okay, hopefully that helps you understand how to do looping in Go. If you have any questions or comments, please feel free to leave those down below, and we'll talk to you again soon. Bye.